Morning. So good to see so many of you here. By the way, I lead the cloud team for Asia Pacific at Cloudera. So been here with Cloudera for almost 9+ years. Worked for organizations like Informatica, Microsoft, IBM, pretty much in the data space for last 22 years. So before I get started, I just want to have a quick raise of hands to understand how many of you really are in the data space, how many of you can relate Cloudera. So a quick raise of hands. How many of you relate Cloudera to a project where you want to do data analytics to be done on cloud? Okay, roughly around 6, 7. And how many of you relate Cloudera to Hadoop? Okay, so looks like set of new audience here. See, the whole goal of what I wanted to get done today is when you go out of this room, our focus is to make sure all of you are really aware what we do in cloud, right? So Cloudera being a founder of Hadoop, in case if you did not know, Cloudera was formed way back in 2008 by 3 engineers from Google, Yahoo, and Oracle. And that's when Hadoop really started coming in. So Doug Cutting, who is the founder of Hadoop, also joined Cloudera. And then from there on, we built a lot of products, a lot of capabilities. Now, in the community, a lot of people still relate Cloudera to Hadoop. Even though we have moved beyond Hadoop, even though Hadoop is core of our culture, we moved beyond Hadoop to provide a lot more capabilities that is required in your data space, right? So end of the day, I really want all of you to know what we do in cloud for your data projects, okay? And our key focus today is you'll see this message very consistently. We don't want to cover the regular sales pitch of Cloudera. The main intent is to get to the technical details so that all the community members really are learning what we have in the portfolio, what we have as a capability. How can you demonstrate the data related projects on Cloudera? That's going to be the main focus today, not a sales pitch. So each speaker will have roughly around 25 minutes of talking, and last 5 minutes pretty much open for Q&A. So if you're not able to finish off Q&A in 5 minutes, again, after the event, we are pretty much here, each of the presenter. So please feel free to connect and get your questions in, okay? So this is what I want to cover today, quickly to give you a quick introduction of what Cloudera is. I'll not spend too much time, roughly around 2 minutes. And then we get into something called as cloud optimized architecture, right? And there is a reason why I put this content to talk about why an architecture which is optimized for cloud is a fundamental principle of our design architecture in Cloudera. And then we get into something called as hybrid cloud. A lot of people really talk about multi-cloud, but hybrid cloud is also an extremely important thing where the ability for you to run your workloads on-prem, cloud, move those from on-prem to cloud, cloud to on-prem, that flexibility. And then we get into specifics of Cloudera on cloud. That's going to be the key aspect of what we're going to cover today. And then since everybody's talking about AI, we didn't want to be left out in AI space. So we'll also talk about what we have to offer in AI space. More than offering, how can you get your AI projects delivered on Cloudera data platform, right? So that's pretty much is the context. So if you look at the data under management, so what is data under management? Typically, the data that an application or a platform is managing, right? And if you put together whole of Cloudera's managed data across all our customers, it is more than 25 exabytes of data. And this 25 exabytes of data, it's again growing. If you put together Databricks and Snowflake, we are probably 50 or 100 times more than what these two companies put together. So that's the kind of data that is currently under management on Cloudera platform. All big enterprises use it for a lot of data related use cases. That's how the data under management within Cloudera platform is extremely huge, extremely big. So the big data, you don't need to really relate Cloudera to big data. I think the number itself talks about the kind of data that is managed in Cloudera platform. Very profitable company, more than $1 billion. Couple of years ago, we went private. So if you don't know about the private and public market, Cloudera was public company until 2021. It was taken over by a PE firm, and now we are a private company, still hitting a reasonable $1 billion revenue in terms of the sales. And then, what is our customer base? Cloudera is used across large enterprises. Large enterprises, when I say global 2000, who's got terabytes and petabytes of data, are probably sweet spot for us, but we also have a lot of smaller customers who are using Cloudera in the overall scheme of things. So Cloudera is used across different industries. And as you can see here, so we have use case that customers are running on Cloudera platform for very traditional analytics use case to next generation AI use case or BI use case on Cloudera platform. All big names, including Experian, Allianz, T-Mobile, Telecomcell in Asia Pacific, Axis Bank in India. So they're all big Cloudera customers who are using Cloudera for both on-prem and cloud. So the reason why I put this slide is to get you all aware of our customer base globally, right? And all of these customers are using Cloudera for varied data use cases. So if you put across any data projects that needs to be delivered for your customer, all of that can be delivered on Cloudera platform, right? So likes of risk management to fraud analytics to network analytics, all of those use cases can be delivered on Cloudera platform. Okay, so what's the focus? A lot of people wanted to know about what Cloudera is, right? And with cloud coming in, and because we were also a predominant on-prem company, our true mission is to get our customers see a real value of hybrid. When I say hybrid, if you have a workload that is running your data center, for all the freshers out here, the data center is something which is non-cloud, where you will typically do it in your own premise. And cloud is something that you will typically do it on AWS, Google, or Azure cloud, right? So when I refer to hybrid cloud, it's a flexibility to our customer to run their workloads on-prem or on cloud or vice versa, and move this around depending on which place offers you the best optimized workload to be run, right? So that's our true mission. So that's what we really want to deliver. We already have started big on hybrid, and we're going to continue to invest more to see hybrid multi-cloud live in action for our customers. The other big thing is modern data architecture. A lot of people still relate Cloudera to legacy Hadoop. As I said, we've gone beyond legacy Hadoop to give you an architecture like Open Lakehouse with Iceberg sort of formats. So we adopted Iceberg much before than anybody else really started looking at Iceberg, right? All of those modern data architecture to run your analytics, AI workloads on top of the platform is the key criteria that we built our platform on. And then accelerate AI, right? Now that you have your data in Cloudera, more than 25 exabytes of data, it makes sense to run your AI at the place where data is, rather than taking out that 25 exabytes of data and run your AI model somewhere else. So we build a lot of capabilities with respect to AI, which I will talk probably the last portion of my slides to tell you how and well we are doing the AI as part of Cloudera platform. So that's the key focus, strategic priorities for Cloudera. And moving forward, so I said cloud optimized architecture. So for all the freshers out here, it may be slightly difficult to understand, but I'll keep it in a simple way, right? So all your on-premise workloads, right, now are getting into cloud. When you say cloud optimized, or when you want to deploy your applications on cloud, what are the fundamental principles? You really want to segregate your compute and storage. That's the primary design principle, so that you can scale your compute independently, you can scale your storage independently. Now in the legacy world, both compute and storage were part of a single machine. And that did not give you flexibility to independently scale. If there was a more data requirement, you still ended up adding more resources, right? Even though there was no compute requirement. On the other side, if there were more requirements for compute, you ended up adding more nodes, even though there was no requirement to add storage requirement, right? So as compared to that, the cloud architecture is more of giving you a separation of compute and storage, right? This one, compute and storage. So when people really started building big data applications, what they really thought about is, okay, let me separate my compute, let me separate my storage. I'm done with it. Now my application is cloud ready. Maybe yes, for a single tenant use case. The moment you look at multi-tenant, where you wanted to do not just data ingestion, but also Spark workloads, but also data analytics workloads, and also ML workloads. Now this is where your cloud architecture really started facing trouble, right? Why? Because nowhere in your this cloud architecture you're managing something called a state, right? The state. All of you are aware of tables. All of you are aware of data. So the table metadata, the audit trials, the user role privileges, the security aspects of it are all state, which pretty often when we look at single workload use case, we forget, because you really cannot store the state as part of your storage because of performance issues. Neither you can take it to your compute because your compute is not always on. So state becomes an important part for you to manage in your whole data lifecycle, and why this is required, right? Now, this is what Cloudera offers. So we have a state which is always on service. So this helps you to deliver your data projects in a multi-tenant way. If you had only one use case just to do your Spark workload, then maybe the older architecture would have been okay. But when you go deploy your data workloads for your customers across portfolio, now the state becomes extremely important. A simple example is, for example, if I start my data ingestion pipeline, right? Let's say Vinay has got access to a data which belongs to Bangalore. If I take example of Axis Bank, let's say Vinay starts a data pipeline project where I'm in a position to access my application data from Bangalore. Now, 6 months down the line, I am also responsible to build my Spark engine for data processing. So now if you don't capture the state, which is metadata, rules, privileges, what you end up doing is you copy this data into different workload. Now you have duplicate copies of your data. And now all the state that I talked about, including metadata, user privileges, you end up copying all of that again. So when you want to keep one state of your storage, you need something called as state, which cuts across all your data projects to keep it low on your data duplication, and also one state which can be used across all your projects. So that's what Cloudera focuses on. And this is a fundamental aspect of how our architecture is built on cloud and also on-premise. As you can see here, this state manages all these aspects. And now if I go to the next slide, and again, this state helps you to go big bang on your data projects. And how it really helps is, now think of the state as this one, which sits on top of your storage. And you have all your compute for your data warehousing, data analytics, data engineering, or machine learning workload. All of it are tied to your state. So the state is something that we refer as SDX, shared data governance. I wanted to put it in a simple way so that everybody in the community really understand why we have SDX in the portfolio. So think of SDX as something that manages state of your data projects, which are nothing but your metadata, governance, lineage, security, audit trail, all of it on top of Cloudera platform, right? And these two are always on. And this is something that comes up based on your on-demand requirements, because compute is something that you can spin up, shut down as and when you require. That's why the top layer is more of a ad hoc thing depending on when you really need your compute coming up. So the whole architecture of Cloudera is built on top of this one. So this is more realistic, simplified architecture of what Cloudera is today. So underneath, you have infrastructure that we support for your deployment. So Cloudera supports your deployment on-premise in your data center and also your deployment on cloud. On cloud, we support the major cloud providers like AWS, Azure, and Google Cloud. And for on-prem, pretty much all the hardwares are supported for your deployment. And this layer, the SDX layer that I talked about, I'm sure most of you have heard about unified data fabric. So the SDX layer can be attached to or mapped to what we offer as part of unified data fabric, which itself is the stored metadata, all of it that I talked about. And the whole open lakehouse is built on top of an architecture which is completely open. So the core storage for that is open format, which is Iceberg, built on top of Iceberg format. And these are all the data services that you see here. So data flow, the data engineering, and data warehousing. So these are all available as a cloud native data services, which are attached to this. Whenever I go create a table in my Spark workload or data warehousing workload, the table information is stored here, right? So that's how there is correlation between these two. And the big addition to our portfolio is the whole AI offering on top of the platform. So be it on-prem or on cloud, we have AI offering which helps you to build your models, take your models from open source, so including GPTs of the world, be it closed source models. All of it can be integrated within Cloudera platform along with inferencing service for all your AI requirements. I'll talk about AI a little bit more in detail in the later part of the presentation, but this is what Cloudera is, a true hybrid. So this architecture is valid for your on-premise deployment and also on cloud deployment, the same thing. So as an end user, let's say if I'm accessing my analytics report of operations or credit risk, if I don't tell the user that this workload is running on cloud or on-prem, you will not know because it is a seamless architecture that sits both on-premise and on cloud, right? So till now, I just want to cover our architecture and what our hybrid story is. So what do you mean by hybrid? For example, large customers who've got on-premise deployments and cloud deployments, the hybrid is all about same code base. If I have 100 Spark jobs running in my data center, and tomorrow I adopt cloud, I can move these 100 Spark jobs without any refactoring on cloud. That's the beauty of unified code base where you really don't need to change anything, right? Just like how you manage your mobile applications data through your mobile app or through internet or through some other mechanism. So think of it as the same experience for your customers to run their workloads irrespective of what the infrastructure is. Okay, so that's pretty much till what we have in the hybrid offering. Now let me get into the cloud in more detail now. I'm sure most of you are aware of this one. What is the difference between IaaS, PaaS, serverless, and SaaS? So we provide Cloudera on cloud offering as a PaaS offering, platform as a service, which basically helps you to manage just your data and application. Rest everything underneath, be it networking, be it operating system, middleware, are all taken care by somebody else. It can be Cloudera or it can be your cloud service provider. That's what we play as a key portfolio as PaaS. And now, what is Cloudera platform as a service on cloud? Now, I'm purely talking about cloud, nothing else. See, Cloudera provides a key platform as a service offering supported on 3 major clouds, AWS, Azure, and Google Cloud. Again, all 3 clouds you can use to host your Cloudera on cloud offering. And this is built in a very simplified way, gives you a SaaS kind of an experience, but yet manage a lot of your data compute in your own network. So think of Cloudera cloud offering as something which is built more for developer friendly, more for admin friendly, more for architect friendly, where they can manage, control all of it with respect to what your organizational requirements are, right? All of it is certified, purely built for very secured, regulated customers. As you can see, we already have all these certifications, including SOC 2. Just as of last week, we got FedRAMP certified as well. So FedRAMP is a certification that is, in case if you're not aware, FedRAMP is a certification that is required for US public sector customers to adopt cloud. So if you're building any software and if you're planning to sell it to public sector or government customers in United States, that software needs to be approved by FedRAMP governance agency. So Cloudera got FedRAMP approved just as of last week. The moderate, we had other two stages already approved. So the moderate is already approved, right? Now, what is our Cloudera on cloud architecture? See, the Cloudera on cloud has fundamentally got two planes. We call it as control plane and data plane. Control plane is an area where is hosted outside your network. So we have hosted this on AWS as a service. So customers log into control plane and send signals to data plane where it is actually running in your own customer's network. So the left side is all hosted in Cloudera's cloud. And the right side, the whole dotted line that you see is in customer's own network. For example, if you are deploying Cloudera on cloud for your customer, right? The whole right-hand side will sit in customer's own VPC, customer's own network. And that's the security guarantee that we give it to our customer, that no data, no compute goes outside customer's network. For regulated customers like Axis Bank, Bank of America, JPMCs of the world, they're extremely particular to host their data and analytics in a secured way. So most of them will not adopt SaaS because of this reason. So most of them have adopted Cloudera and other PaaS offering, which is platform as a service, because they want to have control of data. They want to have control of what's happening to their application. So that's how Cloudera is deployed. And again, the same layer of SDX is also hosted. And all of these are cloud native services, which is built on top of EKS. So if you're relating this to AWS, all of our data services are built on top of container services, which are provided by AWS EKS. And this runs as a cloud native. So the key capabilities are, it helps you to automatically scale up depending on workload coming in, scale down when there are no jobs running. So all of those capabilities are built as cloud native capabilities, including all the data services that I talked about. Okay. So quickly, so this will be covered by Suraj and Manik in more detail. So these are all the steps for you to set up Cloudera on cloud. Basically, the moment you have access to our console, you create something called as cross-account policies, and then you set up your environment, set up your network, and then get your data services up and running. So more detail. So we'll also show a live demo of this one later. And then, so these are all the data services that I initially talked about. Data engineering for all your Spark workloads, data warehousing for all your analytical workloads. We also have data visualization. So if you have a BI reporting to be done on the data, so we also have that as part of the portfolio. Operational database, which is HBase version, hosted as a service in Cloudera. So if you are looking at doing any data projects, you don't need to think anything outside this, right? So usually in your data pipeline, what do you require? I need to collect my data, ingest my data, process my data, build analytics, build machine learning. All of it are available as part of a single portfolio here. Okay, so since most of you are going to be working with customers, so this is how a traditional end-to-end architecture will look like. right from ingestion to doing processing, doing API management, doing your whole messaging layer, and then a lot of AI. So I just want to put this and get you to start relating how Cloudera will fit in into this architecture, right? So we can share these slides. So this is how the whole architecture fits into what Cloudera has to offer with all the data services that I talked about, including data warehousing, machine learning, data engineering, data flow. All of it are a single platform which helps you to manage end-to-end data flow in your projects. Okay. And quickly on AI, again, I'm left with another 2-3 minutes. The key thing is the whole platform, as you see here. So we have integrated AI into our platform to run any of your AI workloads. We have something called as AI Workbench, which you see there, helps you to build your models, train models. And when you deploy, all of those AI models are deployed as part of inferencing service. Cloudera automatically takes care of that. And we also have AI registry for you to manage models from 100 different places. So a slightly detailed version of what we have. So the whole platform takes care of the data wrangling, getting your data prepared. And we also have built integration with open source foundation models, closed source foundation models, the whole ecosystem of vector database, be it open source, closed source, along with you hosting your AI applications. So if you're looking at hosting or building your AI application, Gen AI application, Cloudera gives you place to manage all of it end to end. Okay. And somebody who wants to get started with AI, so we have something called as AMS. So these are nothing but ready-made models which are built for you to do one-click deployment and start using these Gen AI models. So if you really want to learn more about what we have to offer, please read about AMS in Cloudera. So these are all ready-made built-in models, built-in framework for you to get started on Gen AI activities or any ML activities in the portfolio. Last, again, this is what we have to offer on cloud. Simplified analytics, easy to deploy, high security because you manage all of it in your own network, your own data. So the entire data lifecycle can be managed. It's not just for a single point solution, but the whole platform gives you flexibility to run multiple data projects in Cloudera, right? So these are all key benefits I want to quickly touch upon. Last but not the least is flexibility to deploy either on-prem or on cloud. Just a quick introduction to get you all up to speed on what we have as an offering. To start with hybrid and the whole cloud optimized architecture. Then I quickly introduce you to what we have as part of Cloudera on cloud offering, which is probably the best thing for any customer who's looking at cloud adoption on Cloudera. Okay. So do you have time for Q&A or, okay, maybe 1 or 2 questions in case if any of you wanted to learn more about what I just presented.
Hello, I'm Shivam from Christ University, Master Students Learning AIML. So basically my question was, during the AI application slide, connecting the models with our system, do you really call an API from that models or how do you integrate the models for the workflow?
So both options are possible. See, there are open source models and closed source models. And all of these models gives you flexibility to import models within Cloudera. The moment you get models imported in the model registry, so you fine tune those models depending on your requirement. Let's say if their attributes needs to be changed, if you need to get your selection criteria to your own organizational data, so that's how it can be done. So both model can be imported within Cloudera's model registry, or we also have flexibility to call models from external world as well. And when we host these AI inferencing surveys, if somebody else wants to call Cloudera AI models, that option is also there. So think of 3 aspects: hosting the model in Cloudera's AI registry, along with using third-party models, which can be used as part of Cloudera as an API call. And once you build AI application, that application can also be used by your other surround applications as well.
And one more question. how Cloudera is beneficial for a student like me to deploy his own project on Cloudera for an
So,
AI application?
so I see with the AMPs that we have in the portfolio, I strongly suggest look at our Git repository where we have hosted all these AMPs. So there are more than 50 AMPs that our data scientists have developed for students like you to get started with. It's a kickstart to your AI models, Gen AI models. I think, yeah. So these ready-made code are already built along with business application. So you get a complete understanding of AI and Gen AI and how it can be used in data projects.
Thank you.
Yeah.
Hi, my name is Ota. My question very simple. Just is it the feature of this Cloudera seems to be resembling to the Snowflake. So just I want to know the difference and the benefit of the Cloudera.
Absolutely, great question. So, see, Cloudera is started at least 10 years before Snowflake and Databricks came in, and we also changed our strategy. We also changed our offering, rebuild our architecture to be more modern as part of the whole offering, right? So I think you came late. I talked about an interesting metric in the beginning. Cloudera manages more than 25 exabytes of data under management, which is at least 50 to 60 times put together your Databricks and Snowflake as what they're managing, right? So we've been pioneers in the data space along with initial introduction of Hadoop. And now we are also building our capabilities for our customers to adopt cloud and hybrid in a big way. So if you ask me, key fundamental differentiator, I would say hybrid capability. A customer who's looking at deployment or cloud architecture on-prem and cloud, probably Cloudera is the only company which is providing that, along with multiple data workloads that can be run in the portfolio. See, if you look at data, I mean, Snowflake or Databricks, they can do one part of your whole data lifecycle, either analytics or machine learning or Spark-based workload. But in Cloudera, we got all of it covered as a single data lifecycle which can be managed in the portfolio. I think these two are the main differentiator, but there are many other things that we can talk about. Yep. So with that, we will call upon our next speaker.
Thanks, Vinay. It was a wonderful introduction into Cloudera and the different offerings and the benefits of using Cloudera. Next speaker for the day is INR, who will be talking about AWS infrastructure and how data infrastructure at AWS can help you with building a lot of data and analytics workloads on AWS. So over to you, INR.
Good morning, guys. Are you able to hear me? Okay, thank you. So everybody is hearing a lot about Gen AI, AI. Anybody not hearing this word recently? Yes. And every year there is a AWS reInvent happen in Vegas. Anyone aware of it? Okay. So in a keynote, one of the keynote in a Swami clearly mentioned that data is a key differentiator between the value you take it from your AI. So data is a key element. Your organization data is going to bring a value for you. So, and the data, since we have seen in our last session, the whole enterprise data is sitting on a Cloudera, and you want to take a value out of it, and you need to do a lot of data engineering, right? And you need to build a model, train the model, and deploy the model. What are the things you needed to do this? Compute. Data. Yeah, data. We already have a data in a Cloudera. Okay. So what's next? Yeah, models. Okay. We are all genius. We build a model from the scratch. Okay. Forget about the LLM model. That will come later. But if you want to build our model, yes, yeah, we need a model. Then what else we need? Storage. Then? Yeah, expertise. Okay. So let's go with the first one. We need a compute. What kind of compute we needed? You guys working in enterprise or you are going to join the enterprise, they're given access to you, the data is in a Cloudera, now you need to build a model or train the model, you need to know what compute need to be launched. How do you select it? Okay, great. And why do we need to worry about all those things? Okay. And the spin-offs and the green-offs or the economics revolve around it. So that's what I'm going to touch upon in this session. So I'm just taking a little bit out of AI and I'm going to talk about what kind of decision you need to make and what kind of compute offered by the AWS for running your data or machine learning or AI workloads. So start with the first one. AWS Graviton. Anybody heard about it? Great. And what is the difference? Okay, we are using Dell, HP, different laptops, Mac. Okay, Mac have an Intel version. What does the Graviton differ from that compute? Or you would have heard the Dell server on your data center. And what is different from that? The Graviton built on a ARMs, okay? And they have different version of Graviton. Since you have mentioned, while we are selecting the compute, think like whatever, if you don't know anything about what is kind of your workload, you can go with a general purpose workload. And Graviton evolved from 20, for the last 5-6 years, the Graviton evolved a lot. Currently, we are in a Gen 4, Graviton 4th version. And if you don't know what kind of workload you are going to use, you can use a general purpose and compute optimized. Think like if you are building any application, when do you think it is a computer? How do you identify it is computer optimized or memory optimized? Okay, so if you find simple, you developed an application, it's a data-centric application. The data is in Cloudera and you build some application which read the data from that and you deployed in a EC2 instance. And if you are with a general purpose, and if you find the memory is only 30% and the CPU is going higher percentage, then you can select the CPU percentage. I'm giving you the data-driven decision to select the right instance type. Then comes the memory instances. Take example, if you have a database, data-centric application, database running on it, so you need to choose a memory instance. And if you are running a Cloudera, there are recommendation. So I see a lot of instances are recommended on the memory optimized. Okay, so Cloudera can run on any cloud. If you are running a Cloudera on AWS, you can select the instance type. The preferred option is memory optimized and the storage optimized. If you have a dense storage, you can, where you want to accommodate a lot of data on the same compute, then you can store it on it. Otherwise, if you find S3 will solve the purpose for you. Then comes accelerating computing. What is accelerated computing? Tensors is kind of an accelerated. What else? And why do we need accelerated computing? Okay, high performance computing, this kind of, I still find it as an architecture. Okay. So what is called accelerated computing? Does my laptop is not accelerated compute? And what kind of compute laptop you are using? Just let's say. x86 64, okay. And anyone is using Mac Pro? I still consider that as an accelerated computing because you have GPU in it, okay? So, okay, so just to make your understanding easy, okay? And this is a configuration, number of cores. And one thing I want to check on this is it's ARM-based architecture. And this is a different version of the Graviton processor. And this is a ARM architecture revision. So current version is ARM 9.0A. Okay. Why do we need to worry about this compute when Intel is solving the purpose? Anyone has idea? Why? Yeah, power consumption, that's one thing. Finally, it comes down to the cost. So there are the metrics. I think I have it in a slide. Maybe at the last I can show you. There is a metrics where if you are using a Graviton processor, you can bring down the value up to, I think I have it. 1 minute, sorry. Yeah, this is the one. Graviton support. So you see the Spark workload, right? Most of the data engineers or most of the even machine learning engineers work on a Spark. And if you have a Cloudera, you can launch the Spark instance from there. And if you are using a Spark on a normal instance, okay, or normal EC2 instance, non-Graviton instance, and if you're running the same thing on a Graviton instance, you can see 23% cost savings or uptime or faster response, okay? And what does it brings in, okay? It brings cost optimization. So that's where I'm coming down to. So while you're selecting the instance, you always check on the cost. What kind of, first you need to think what kind of workload it is, whether it is a general purpose or memory or data intensive. Based on that, you can decide whether to go with the x86 or ROM-based architecture. And Graviton processor is AWS grown processor. And there are the areas you can see more than 30 to 35% of the optimization. It is not only available on EC2. Anyone worked on Lambda? Where you are you running on x86 or you know there is option to run it on Graviton? Anytime you tried it? Okay, easily can give a 30%, but you need to do the testing. Anyone tried Lambda on Graviton? Okay, what is your lessons learned from that? Will it work directly if you're working on just to click on a Graviton, will it work? Yes, there are some library to be done, okay? So for your information, when you are running a Cloudera natively support the Graviton process. Okay, let me go to the next one. Okay, now coming into the accelerated compute, okay? And why are we talking about accelerating computing now? See, most of the workload, you may have a data in a Cloudera. When you train the model, you need to train fast and you need to train in efficient manner. Okay, that's where the accelerated computing coming. It's not only training. When you are doing an inference, where does the cost goes a lot? Imagine you build you guys build a nice chat GPT kind of tool by yourself, and we are giving you 1 million to run it. Okay, where the cost will go? Training or inference? Inference, because once you are successful and a lot of people are using, the inference cost a lot. Okay, so that's where there are different compute type for inference, different compute for a training, and we are going to touch upon how we are going to use it. Okay. And these are all natively supported. If you have a Cloudera and the data is there, you can, from there is an endpoint, the notebook, you can select the instance type, whatever the instance type you have, we can select it and train it from there. G series instance, we touched upon. Okay, it's on the Graviton only, but it is accelerated computing. I'll come to the P series. This is from the NVIDIA. So I don't need to give an introduction about NVIDIA. Just 10 years back, still people give what is NVIDIA is doing. And AWS, I can remember 2017 onwards, 2016 onwards, I can see NVIDIA compute on AWS. I done by hand, so I don't know how it worked before. Why do we need it now? Imagine you have a exabyte of the data and you want to build a model for your enterprise. Okay, and you want to take some base model and you need to fine tune the model with your enterprise data. You need a compute. And these are all the offerings from the AWS. From Cloudera, the data is there. There is a studio called fine-tuned synthetic data. I will show you that one. From there, you can synthesize your data for your model training, fine-tune your model, And while finally tuning the model, you can run on any of this compute, which will give you. And anytime imagine I want to build a model from the scratch. Okay. Anyone heard about stability.ai? Stability.ai? Who create images? Okay. They were using the ultra cluster. What does ultra cluster means? They will bundle down a lot of P5 instances, stack it, and run this one. Okay. GB200 architecture. So multiple GPUs are there, and the GPU to GPU communication will run through the CPU, and they will stack it as a big hardware that is also available in AWS. And anyone heard about Blackwell? Blackwell? Okay, so Blackwell is a supercomputer from the NVIDIA. And how this architecture is the same thing, like you will have a GPU, multiple GPUs, and it will GPU to GPU communication will go via CPU, and they have a strands nothing like our spines. For that, they are using a NVIDIA NVLink or NV switch. With that, they will make a big supercomputer. And the first cloud provider to adapt this on the public cloud to the customer is AWS. The Blackwell compute is available on AWS. Okay, these are all the offerings from the NVIDIA. Since most of the team knows NVIDIA is for the accelerated computing for model training. So these are the compute you have. And if your data is in a Cloudera, you have a native integration to the AWS where you can select any of this instance for your model training or fine tuning. Here comes the Inferencia. Okay, what is Inferencia? It's again a homegrown tool by AWS for the inference workloads. There are the case studies. People have saved more than 80% on the inference cost using Inferencia. Okay, and there are variety of Inferencia. Currently, we are in version 2 on the inference. Okay, so this is the architecture. There are 4 ranges are there. You can select based on your requirement. Then comes the Trainium. Trainium, we are in a 3rd version of the Trainium. Trainium is custom-made chips again by AWS. Still, it is for developing your large language model, if you say, right? And when compared to the GPU from the NVIDIA, if you are using a Trainium, you can save up to 30 to 40% of the cost. Okay. And there is the same thing. You can use the ultra cluster. We have seen some ultra cluster on a GPU, right? Where we will stack up all the GPU to make ultra cluster. Same way, you can stack up with all the Trainium cluster node and create an ultra cluster. And you can stack up using, there is something called neuron link, like how the strands I told to, if you have multiple GPU, you need to plug it and you need to have common, right? They have an NV switch. Here you have something called neural link. With that, you can connect all your Trainium cluster and make an ultra cluster for your workload. So this is one of the use case for summarizing app. You saw there is a catalog they have shown, AMP, which all the model provider from the Hugging Face and other things you can see. From there, you can select any of the studio or access. I'm gonna show something on a UI. Best of my knowledge, I'm gonna show. And you can select any of this one. And if you want to deploy the model, you can select any of the instance we have shown before. So the reason why we have to choose this kind of option is if you are already having a data, you should not move closer to the model. With the option of the AMP, the model you can deploy and you can have a tight integration between the model from your platform in the same Cloudera platform, and you can deploy on a AWS compute. And whatever the instances we have seen, if you are using a classic machine learning model, you can deploy on a Graviton. If you are using a large language model from the Hugging Face, based on the requirement, you can select whether you need a 1 GPU or you need a 3 GPU or 4 GPU. Based on that, you can select. If you're already your company want to use only the NVIDIA, you can go to the NVIDIA, you can select the model and deploy that. And if you want to choose any of the accelerated compute from the AWS for the cost optimization, you can use Trainium. Once you train the model, if you want to deploy, you can deploy an inference here. And this is, I'm going to show in a console. So any questions? Now this, just to take a little break from AI, I want to touch upon a compute differently so that you have some awareness. AI is just a tool we are building. For that, the data is a differentiator. To make a value of the data, you need a compute. The compute offering, you can find a best in class from the AWS. So any questions before I'm going? And just to give it 2 minutes on what is this AMP. So come here, Cloudera. So this, I'm on a Cloudera AI workbench. Anybody can log in. Truly speaking, I was testing this 1 week before, but I forgot it is only 5 days license. So I came now. When I logged in, I said my license got expired. I spanned this in a matter of first, the speaker gentleman speaking, just before that I was doing this. So if I can do it, you can also try it by end of the day. Okay. So come here, AMP. You see a lot of options are there. So if you want to select some model, you can select the model from here. Anybody know Code Llama? Okay, what does it do? Yes, and Mistral and DeepSeek. Okay, so if I want to deploy, I don't need to do anything. Click here. I'm in a Cloudera AI workbench. Click here and click on configure. And it will ask what GPU you needed, everything. And you need to see number of GPU you needed, everything. And of course, I need to give my AWS credential. I'm not doing this. Okay, it's very expensive. When you are doing it, you do with cons. Okay. Okay, so this is the option. And you can do the deployment of the model from here. You can select AWS instance, whatever you want. I have done something. Anybody heard about agents nowadays? Anybody is hearing about AI agents? Okay. Okay, so anybody build an agent so far? Multi-agents? Okay. And what is the toughest part? Writing a prompt or setting up an environment? Writing a prompt. Okay. Writing a prompt is, okay, we'll all consider writing prompt is toughest one. Writing a prompt is easy, or monitoring whether the model runs successfully or the workflow run successfully is easy. That is not easy. Okay, I'm just asking. So that is not easy. With the AI Studio from the Cloudera, Agent Studio, you click on it. With a single click, it will deploy everything. And it will come with the monitoring also. And you can connect with your enterprise data. I tried this. I have a running agent. Unfortunately, as I mentioned, I could not change it. So this is the agent I taken from one of the template and just agentic workflow. I selected one of the sales LML. Just go to the agent. Come to the AMP, click on the agentic studio. And the moment you configure and deploy, it automatically deploy. Once you deploy, you can come to the projects. So you can see testing Bedrock. Yeah, this is what I'm doing. So here I launched the Agent Studio. So here you can see it taken, I say 20 minutes to set up everything. It comes with all the observability, monitoring, set up the virtual environment, Python package, everything it will done. And it's give a clear UI where you can come, select your agent, set up your task, and whether it's a capable, whether it need to be conversation agent or it's a workflow supervisor agent, everything you can configure. And post that, you just deploy. It's a single click deployment you can done. So I'm just doing the test workflow. I need to give a prompt. Okay, required tool is missing. Okay, so I'm just giving you a glance. So anybody want to play around, go ahead and play around. Yes, you need to integrate with their API. You can get a free API from the OpenAI. You can use that API and add those APIs. You can build an agent in an orchestrator format. in a plugin too. They already have multiple templates. You can pick one and play around, change the prompt. So that's all you can do. And that's all. It's me. I'm INR J. Krishnan. I work for a financial organization. I'm a AWS ML hero. I'm part of AWS UG group, UG Bangalore group. Thanks for joining today. Nice connecting with you all. Have a great day.
Please. We are good. Thank you. Thanks so much, Ayan.
Thank you.
So as of now, we are done with 2 talks from Vinay and Ayan. A lot of, knowledge session, understanding. So for some change, now we'll go with demo and use cases. So I'd like to call Manik and Suraj for that. Thank you so much.
So hello, everyone. I hope you're having a good time understanding what Cloudera and what AWS can sort of do together. We've heard both speakers talk about a lot of capabilities, and now we'll try to showcase some of them as well, right? So you get an idea as to how the platform looks like, how it integrates with AWS, and so on. So I'll quickly share my screen. Okay, so before we get started with all the capabilities, right, I just wanted to get started with how you go and install Cloudera on any of the cloud providers, for example, AWS, right? So initially, it was a very wizard sort of a driven process wherein you would enter informations, you would create a cross-account role in AWS, link it up with your control plane in Cloudera, and then go and do the installation, right? So it was a very wizard-driven process earlier. But since a lot of organizations started to move towards automation, we've now moved to a fully automated Terraform way of deploying Cloudera on public cloud as well, right? So these steps that are mentioned here are basically agnostic of where you're trying to deploy Cloudera, the cloud provider, right? So it makes it a whole lot easier for you to follow the steps and go over them in a sequential manner, and then have your deployment up and running, right? So very simple deployment. If you compare it with an on-premise deployment, there is a lot of prereqs that come into before you could even start doing an on-prem deployment, right? But for cloud, it's pretty straightforward because you have the flexibility of deciding your compute later on as well, which you can't do in an on-prem world. You have to buy the hardware and have it ready for you to use, right? That's something that cloud solves. So this is how we go about with the setup. I just want to also sort of showcase the architecture that Vinay was initially showing. And using this, we will go to the interface and we will be able to connect what we are looking at in the interface, right? So there are 2 blocks here. The first block is your control plane layer, and the second block is your data plane layer, right? So whatever happens with the customer's data happens on the right-hand side of this image. The left-hand side block that you see is only, it's basically for you to control your deployments, manage your workloads, look at what's happening within your environments, right? So that's only your control plane layer. And now if I open the interface for Cloudera, just give me 1 second. So when I open the interface for Cloudera, this is how it looks like, right? So like I said, the interface that a user is going to use is going to be the control plane. So if you look at this image, the access to all of this comes via this block here, right? So the CLI, the web UI, or via SDK, everything that you're going to do on top of the environment is done via the control plane. And the control plane looks something like this, right? Now that we have a control plane, you might be wondering that Cloudera is talking about being able to go and sit on cloud providers, right? And you can manage multiple cloud providers from a single place. So how do we do that? So as part of this control plane, there are a few services that you can see here. I will talk about what these services on top are. Vinay has already spoken about them. We will do a small recap. And then you have a few other set of services which help you manage your entire deployments, right? So you have a management console where you go and set up your data plane, the right-hand side in the architecture diagram. You have observability. So this again is a new introduction as part of our portfolio. Customers were running a lot of different kind of workloads and they wanted insights as to compute related governance, right? So for example, if I'm running a SQL query, what is the compute associated with me running that SQL query, right? Or what is the kind of cost that I would incur if I'm running that SQL query? So for these kind of insights, we have an observability service. Replication manager is used in case you want to replicate data, for example, a DR use case, right? So this can be helpful there. You have a data catalog, and this is like a window or a governance for your entire all the data entities within your system, right? So for example, if you have a table and you want to see what is the schema of that table or how does it look, or what data you need to access to arrive to a specific insight, right? So the data catalog will give you a good view of what resides within your entire data landscape. And you have data hub clusters as well. So I'll talk about data hub when I talk about these services on top, so that you get a clear differentiation between what these two are, right? So I wanted to show this management console. So this management console is from where you would go and install Cloudera to start running your workloads. So you can see we have 3 different environments running here. And all these 3 different environments are on 3 different cloud providers, right? So one is on AWS, one is on GCP, and one is on Azure, right? So this is the beauty of the control plane, that irrespective of where Cloudera is deployed on whichever cloud provider, you can manage everything from one single place, right? So that's the power that management console brings. And then if I go into a specific environment, say let's go into the AWS environment, you will, can someone tell me what was the layer of the state that Cloudera was maintaining, right? So when I spoke about a layer in our stack where we maintain the state of whatever is happening. So does anyone remember what that was called? Yeah, SDX, right? Shared Data Experience. SDX is basically built off open source, so different open source services that is powering SDX, right? So there is Apache Ranger. Has anyone heard of Apache Ranger here? Yeah. So Apache Ranger basically helps you create access related policies, right? So I have ingested a data into a specific table and I want only the marketing team to be able to access that data, or I want only the sales team to be able to access the data, right? I would need to go and create a security policy on top of that table. So SDX is where I would go and do it. But within SDX, Ranger is the service which is responsible for access related control, right? So if I have to access Ranger, you can see that it sits right within your SDX that is part of your environment. We have another service called Atlas. And Atlas is important because a lot of financial enterprises that you work in or that you talk to, right? Governance is a big aspect and a very important aspect for all those organizations. They don't only want to know what their data is, but they also want to understand where it came from, who accessed it, who did what with it, and where did it end up to, right? So you need to be able to capture the entire lineage of that data entity, right? So it's very important for a lot of enterprises to have that information, so that any regulator comes and asks them to be compliant and they have to give back reports, that's an easier way for them to prove that how they have a governance layer around their entire data, right? It's not like they just have customer data sitting inside. There is no layer of governance, there is no layer of security, and anytime anyone can take that, right? So they need to prove to regulators that it's all governed and secured. So Ranger and Atlas basically helps you do that. And both these services are part of our SDX layer, right? That's how they maintain the state of whatever is happening within an environment. So that's about the environment. And now if I go back to the home page, and we'll talk about the different services that we have on top here. So like Vinay mentioned that we touch the length and breadth of the entire data lifecycle, right? So right from data ingestion, once you ingest the data, all of us know we cannot use data in its raw form, right? There needs to be some sort of transformation, some sort of processing that needs to be done so that you can work on that data, right? So that's where your data engineering comes in. So the data flow will help you ingest the data. You have a specific service called data engineering, which makes you do something with your data. Once your data is transformed, it's cleansed, you would write it to a storage, right? Once you write it to a storage, you would build tables on top of that. It could be Hive tables, it could be Impala, it could be Iceberg, right? You have different engines, you could build tables on top of that. Now that you have tables, you would want to write SQL queries, right? You would want to build dashboards on top of those data sets. So data warehouse gives you that capability to do all of that, right? You also have an operational DB, which basically acts as a database for maybe user-facing applications, right? And with the help of the data warehouse and operational DB,
Cloudera makes sure that all of your data sits in one single place. And given that it's in one single place, you can provide access in a more efficient manner. People can access, right? So consider an example that I'm a business analyst and I have to give a report to the C-level executives about how the business is going. So I would have to go and talk to each and every line of business, right? So there's a marketing team, there's a warehousing team, there's a supply chain team. So I have to go and talk to them and tell them, okay, I need this data from you. Everyone is maintaining their own databases, own tables and all of that, right? It's not standardized. So imagine this scenario where I had to go and talk to each business line, get the data from them, then do my SQL and analytics and then share it. So I have spent so much time in doing all of this. And by the time I share insights, they might not even be valuable, right? So we are living in a real-time world. You need to be able to do all of this in a very fast manner as well, right? So having all the data in one single place makes all this process very fast, right? So for enterprises to be able to get meaningful insights, it becomes even more better because they have access to data which they earlier did not have easy access to, right? So with these two services, we enable that. And Cloudera AI, I think all of you have seen a glimpse of what Cloudera AI can do. If there are any data scientists in the house here, Cloudera AI can help you with right from your exploratory data analysis all the way till you do your AI inferencing, right? So everything in between can be taken care within Cloudera itself. So you have all suites of services which help you take care of your entire data lifecycle. Now, the beautiful part about these data services is that on cloud, all these data services are containerized, right? So which means that you get the power of adaptive scaling. You can scale up and scale down based on the volume and velocity of your workloads. But Data Hub, on the other hand, is not a containerized compute, right? So Data Hub is very similar to the legacy way of doing things. So when I mentioned that in the legacy world, storage, compute were co-located, right? So you couldn't independently scale either of them, right? If you scale the compute, your storage automatically scaled along with it, even if you did not want that. So Data Hub is pretty similar to that. It's not containerized. And the reason we have Data Hub moreover is so that we can make it easier for our old customers who are on the old architecture to quickly jump onto the new platform here. But it also gives you a flexibility that within a single cluster, you can have a data flow job running, you can have a data engineering job running, you can have all these different jobs running within that single cluster. And how do we do that? We can do that because all these services that you see here, these are abstraction of certain open source technologies that we run at the back end, right? So DataFlow at the back is being powered by Apache NiFi. So I hope all of you have heard of Apache NiFi. If you've not, it's a great ETL tool. And DataFlow is powered by Apache NiFi at the back end. Data engineering is being powered by Spark and Airflow. So I'm sure you guys would have heard of Spark, at least in the previous slides that you would have seen, right? So Spark is used for data processing. And we've created an interface in such a way that it's easy for a data engineer to start using Spark, which otherwise is very hard, right? Because you have to do a Spark submit, you go and check for logs, driver logs in one place, executor logs in the other place. It's a whole lot of circus that you need to do to be able to manage Spark workloads. So that's what we are trying to solve with these data services. This is your Hive, Impala, Iceberg, all of that sits here. This is your HBase and Phoenix, right? And this is our own Cloudera AI service. So you can see that we are committed to all these different open source technologies, and we want to make it easier for the users who are using these different technologies in a more, I would say, self-serving fashion, right? So now we'll take a look at what these different services are and how they are used. And I'll also give you a short walkthrough of what kind of pipelines you could build as part of Cloudera, right? So you have seen already that you have all the environments sort of set up here. And for example, I need to now start creating a data ingestion pipeline. So I would go to DataFlow. As part of DataFlow, I have something called a flow designer. So a flow designer is a sort of a low-code, no-code interface, which is built on top of Apache NiFi, where you can design all your different kind of flows, right? Say, for example, let me just maximize this. So if I go into the flow designer, you will see that I have a canvas wherein I can drag and drop different kind of processors and design my entire flow as to where the data would come from, what needs to be done on top of that, and where it would go after that. So I can design all that as part of my data flow. I can test it here. Once I finish testing it on an active session, I will add it to a catalog, right? So this takes care of my development and testing phase. So I can do that here. Once I realize that, okay, this is good to go, I will publish it into a catalog. And if I go to the catalog, you will see that the branch management flow will show up here, right? It's still not running. It's only a part of a catalog, and anyone in the organization can operationalize this flow or configure it based on their requirement. So you can design flows in a reusable way, right? So now I want to deploy this flow. I want to make it to start run, right? So when I click on deploy, this is a wonderful part of our platform, right? So right now, you see that there are 3 different AWS environments here, but if there were Azure and GCP as well, you would see them listed here. I have done the development, and now I am at the stage where I want to start running the flows, right? So my development was agnostic of where I want to deploy the flow, right? At the time of deployment, I have a choice whether I want to send that to Google Cloud, I want to send that to Azure, or I want to send that to AWS, right? So I can decide that at the time of deploying my workload, right? And it's the same scenario for any data service that you see, which is there in our portfolio, right? So that's the simplicity that we try to bring. And anytime you do any kind of development, you would have seen that I did not open the cloud providers console. We did not open the AWS or the Azure or the GCP console, right? You're doing everything within Cloudera itself, right? So all our data services are designed keeping that kind of an architecture in mind, that your development will be agnostic of where you want to run those workloads. Right. So on the same lines, like I was talking about one of the use cases, I have done my development of creating certain flows. So this is a very simple banking use case wherein I'm trying to create a dashboard to understand how specific branch of which are under the bank are performing, right, in different aspects. So there are different sets of data that I would need to ingest. It could be your core banking data, or maybe data from your footfall camera sensors and things like that. So I come to data flow. I design all my flows here. So you can see that there are different flows with respect to core banking, financial reporting, footfall data, and all of that. Once I've developed these flows here, I've added to the catalog. And after adding to the catalog, I've also deployed them. So once they are deployed, they will look something like this. So your flows, they could be running anywhere. All of them would be listed here. You could see certain amount of graphs with respect to how they are performing. If there are any concerns or if they're running fine, you could also see their status here, right? So these are operational flows, right? And these are basically ingesting data to, so what is the storage when we work on AWS? Anyone? Yes. So S3 is the place, is the object store that we are sending all of this data to, right? So once the data goes into S3, then we can start going and building tables on top of this data. You can create your Hive tables or iceberg tables. And for that, I have come to the data warehouse service now. So data flow is done. We have designed the flow, we've deployed it, it is running, and it is writing data, getting data from somewhere and writing it to our storage. Now with this, if I go into this CDW or data warehouse editor, you will see that all the databases that we were earlier talking about are now sitting right here, right? So you can see the branch database, the campaign, the footfall sensors, all of that sitting here, right? So now I can write SQL queries, I can understand, I can share reports, I can understand and get more insights from my data because I've been able to ingest it from different kind of data sources, right? It's all in one place now. And also what I can do is within Cloudera Data Warehouse, you have an option to create dashboards as well. So you guys would have heard of Power BI and Tableau and all of this, right? So CDW is something of a similar kind of a tool. And we have it within our own stack. So you don't have to look at an external BI tool, right? So if I go to data visualization and if I open this, you will see that a simple dashboard is what that we've created based on all the data sets that we were ingesting, right? So right from data ingestion, we did not do any data engineering here, but you could also do some data cleansing if at all it was required. Because we were generating dummy data, we just generated the right amount of data and we didn't have the need to do engineering. So you saw the data warehouse, and then you also see a dashboard at the end of it, right? So it's very easy when you are on a single platform and having all these different services at your thing, right? For you to start using. Someone had a question around how all of this is different from Snowflake, right? So if I were to talk about Snowflake, so Snowflake basically, so Snowflake only does this, right? So whereas Cloudera takes care of the entire data lifecycle, right? So that will give you clarity around how we differentiate ourselves with the competition. And if you, for the likes of Databricks or Confluent, they are only point solutions that are taking care of these stages. They do not give you an end-to-end solution, right? And when you work with point solutions, security and governance sort of becomes very hard to do, right? Imagine you were working with Confluent, you were ingesting data through a third party, you created security policies of who can access that data and who cannot access the data. The data was sent to another competitor or another third party application to do data engineering. But this will not know what were the security policies that were created here, right? There is no sort of integration at that level between different organizations. That's the problem that we are kind of trying to solve, right? So I hope that gives you an idea as to how our platform is structured and what it can do. I'll open the floor to any questions that you have, and yeah, happy to take that.
Any questions, please? Cool. We are good then. Thank you
We're
so
good?
much, Manik.
Thanks, guys. Have a good session.
Thank you. So after this, we have one more session with Suraj. He works with Cloudera. I'll request him to come. Thank you.
Has anybody used Cloudera Public Cloud, the screens that were shown? Or many of you are new to what was shown? Anybody? No? Okay.
Check. I'm good. Thanks. So, good morning, folks. Audible? Yeah. My name is Suraj, Cloud Solutions Architect, AWS. Sorry, AWS in my previous role, now Cloudera. So before Cloudera, I was with AWS and GE and Realtor.com. Before that, where I would build and manage data infrastructure. So today, let's see how we could build secure data platforms on the cloud. And this is what I plan to cover today. The need for secure data platforms. Why do we need a secure data platform in the first place? Then we cover an architecture overview where we would walk through who's responsible for what. And we also briefly talk about the control plane and the data planes. We then talk about user management. We look into types of users and accesses. The fourth topic would be looking into things like Ranger, encryption, Knox, Atlas, Octopi, which is our latest AI offering. We'll then wrap up with a quick overview of monitoring capabilities of Cloudera. So you would be surprised to know over the last 10 years, the amount of data generated globally has grown over 20x. That is from about 9 zettabytes in 2013 to about 180 zettabytes projected in 2025. So fun fact is that's more or less like every person on earth streaming Netflix continuously for the next 30 years. So that's the kind of data we have generated today. So it's clear that we are collecting more data than ever, right? Be it customer data, finance data, operational data, and so on. Now, without proper controls, that data can soon become a liability for us, right? So secure data platforms like Cloudera ensure that your organizations can protect customer trust by preventing unauthorized accesses, meet compliance with global regulations like GDPR and HIPAA, safeguard IP, and also enable collaboration, most importantly, enable collaboration across teams without compromising on data security. So in short, security isn't just about locking down data anymore. It is about enabling safe, compliant, and scalable access to power your data business. Let's watch this video to understand how an unsecure platform can soon become a major liability.
See anyone? There's nobody here. Hey, someone's coming. Go! I get the door. Wait, should we wait and talk to him? Get in the fucking door right now. What's the joint? She can flag him down, but maybe they know something. There's no one in that car. Huh? I got this car.
Yeah, so what do you think just happened? Any guesses? Yeah, so somebody, a hacker or a criminal, has hacked into the auto manufacturer's platform, managed to push a faulty code onto all the self-driving cars. And the self-driving cars are acting on its own, crashing into each other. This could be the new war mode as well. As you have more and more autopilot cars coming up, this could be one of the attacks. So it's clear that securing your data platform is not negotiable anymore. It is extremely important. It is day zero for all companies, and it's been day zero for Cloudera ever since. So Cloudera works on a shared responsibility model. Now, what does that mean? You saw Manik demonstrating a control plane, and we often talk about a data plane. So the control plane is hosted and managed by us, which is on AWS. The data plane is something that you manage. It is where your data sits in. Could be any cloud, right? So that is something that you would manage. But of course, we are there to help you manage and secure that data. So we provide the tools and technologies to keep your data secure, but you will be clicking that button, ensuring your data security. So we have something called the Cloudera Trust Center, which brings together the latest Cloudera security, compliance, and system performance information all in one central location. So you pretty much have answers to all the questions with regards to security governance, network security, current attestations and certifications in this link, that is trust.cloudera.com. Would like to highlight that we recently were FedRAMP certified. FedRAMP stands for Federated Risk and Authorization Management Program. Think of it more or less like a center or an approval body which would allow you to host sensitive data on this platform. So you'd be surprised to know there are not more than 400 services, not companies, but services who are FedRAMP certified. So with the cloud, the CSP, that is the cloud providers hosting about 350 services each, you can imagine that these guys take a lion's share with those authorizations. So overall, not a lot of companies out there that are FedRAMP certified. Now coming to the deployment modes, On a very high level, we support 3 deployment modes: a public deployment model, a semi-private deployment model, and a private deployment model. Public deployment is where your entire stack, that is the stack that is the data plane which is hosted on your cloud, would be on a public subnet open to the internet. Semi-private is where your endpoints such as the Yarn, Hadoop, Hive, Hue, the services that you host are on a public endpoint, but the data and compute sits in a private subnet. Private deployment is where your entire stack is on a private subnet. Now, we typically recommend public and semi-private for quick POCs. Production is strictly private. Now, the reason why we recommend or we don't recommend public, but public is an option because it is the fastest. And by fastest, it does not mean that it takes more time to deploy. It's simply because companies or enterprises have to go through an approval process to have few of their endpoints or ports open in case of a private deployment. So from a deployment per se, all 3 takes that same time, but it's just that companies need more time to prepare for a private deployment. So this is how a private deployment would look like, where the entire stack is deployed on a private subnet. And a semi-private is where you make use of 2 subnets, a public deployment to manage all your endpoints, a private subnet for your compute and storage. A public deployment is where the whole stack is on a public subnet. Now, coming to user accesses, there are 3 main components that you would need access to: a Cloudera manager, used by admins for Cloudera access and management, cluster UIs such as your Hue, Ranger, Uzi, Yarn, and a few other services. And then you have other endpoints that refers to programmatic access to the same set of services such as Hue and Ranger, but that is using APIs or JDBC, ODBC clients. And ideally, we want all of these access to pass through something called an Apache Knox. Apache Knox is like a gateway that would ensure secure accesses to all of these services. We'll dive into Apache Knox into a little later in the next few slides. Coming to SSH accesses, there are 2 levels: an admin with root access and another user access, which is more restricted in nature. And this user access is managed by the free IPA or Kerberos servers. Now, Cloudera can integrate with pretty much all the IDP providers out there. The only requirement we have is the IDP provider needs to be SAML 2.0 compliant, which is, I think, pretty standard across all IDP providers these days. Now, getting into secure data ingestion, storage, and access, pretty much everything that is, be it right from the control plane to the data plane communication, and the control plane, the data plane, is encrypted in both REST and transit. Cloudera uses self-signed certificates provided by Let's Encrypt in the control plane. We also do support AWS managed keys for a few services. We do support customer images in case customer has any additional hardening rules. All of our images are CIS level 1 certified. CIS stands for Center of Internet Security, an organization focused on improving your cybersecurity. Now, these are some of the services that help with secure data access and governance. Now, if you see all of these like Knox, ID Broker, Ranger, and Atlas are free. So you don't pay for any of these security services on Cloudera. The only thing that is paid is our latest AI offering, which is Octopi. We'll get into details of each of these services. Apache Knox is a gateway. So if you're opening your Cloudera environment to internal teams, partners or apps, you need a way to control and secure external access. Now imagine you have 10 different services, such as Hive, Yarn, Ranger, or Atlas. Managing and securing each of these endpoints could get challenging, right? So this challenge or problem is solved by what we call Apache Knox. It acts as a gatekeeper between your users and the data services. So instead of letting every user connect directly to a service which is hosted on Cloudera, you now go through these services or access these services through Knox. So far we have seen how users using their own identity providers can log into Cloudera. Now, in Cloudera, you create your own roles or groups, such as an admin group or a data engineering group or a data scientist group. Now, all of these services need to talk to AWS. And AWS would not understand these admin or data engineering groups. What they understand is something called IAM, which stands for Identity and Access Manager. So you need a mapping between Cloudera and the AWS compute resources or storage resources or any AWS resource. So this mapping is done by what we call an ID broker service, and the mapping as such is called the ID broker mapping. Now, Apache Ranger is a centralized framework for data access control and auditing. So you have tables, Kafka pipelines, HBase, Hadoop, and all of that sitting in Cloudera, right? So Apache Ranger is a one-stop solution where using which you can manage and control accesses to all of these services. So it provides fine-grained access control at various levels. Like say you're using Hive, which is like a database. It provides database, table, row, and column level security to your tables. HDFS, it provides directory and file level access, provides topic level permission access to Kafka, namespace and table level to HBase. Apache Ranger also supports tag-based policies. It also supports multiple authorization models such as RBAC, ABAC, and time and condition-based policies. And you could also apply rules based on IP addresses, user groups, or time-based conditions. That is, allow access only from a particular IP or for a particular user group and things like that. Now, Apache Atlas is a centralized metadata and governance framework that can be used for your metadata collection. Now, you could easily integrate Atlas with services like Ranger that we saw earlier to enforce dynamic and fine-grained access control. Now, Atlas is good. Like you could do data discovery, data lineage, all of that. But that is restricted, or the scope of Atlas is for your Cloudera environment as such. Does not go beyond Cloudera. And a lot of customers usually have integrations with a lot of different systems, like say Oracle, SAP, Cloudera, and so on, right? So we needed a data lineage or tracking system which could provide a data lineage or track down across different domains, across different sources. Octopi is the solution for that. Now, using Octopi, you could, along with your data lineage, it helps you with your data discovery, and also builds a data knowledge hub. And the cool part is you could get all of this information real time using the new agentic AI tool called the Optimize AI. Now we'll see how Optimize AI works a little later in a demo that Manik would provide soon after this presentation. Coming to monitoring, these are some of the tools that you could use to monitor. Cloudera Manager, Grafana, integration with CloudWatch, Apache Ranger, Octopi, SSM for your streaming service, and so on, right? But what I would like to highlight is Cloudera observability, which is also used by Access. And we were just talking well appreciated and taken by Access. And this could be your one-stop solution, replacing most of these services. And a key feature that stands out for most of our customer is what we call the financial governance. Now, usually data lakes or data platforms are shared across different teams. And we often hear from customers if there's a way to charge back to these individual teams. Not a lot of companies or tools have this, but what we have is something called the Cloudera Observability Premium, where we can charge back and get visibility on the spend. We can create cost centers and chargeback models based on consumption, and also charge specific teams based on their usage. So this tool gives you insights into user level as to how many queries or the data read, or how expensive has each user or user pool been to the Cloudera platform. Yeah, so I think end of this discussion, any questions? I know there were a lot of topics that we touched upon. Any questions that you have? So we want to focus more on our data services. Like you are aware, there are data hubs, data services. So we want to focus more on data services because that is based on more or less what we call the next gen architecture using Kubernetes and containerizations. And also we are working on what we call a unified code base, which is already available, but we want to continue working on a unified code base. Like say until last December, the code base for on-prem or private cloud was different from public cloud. Now we want to, in order to be cloud agnostic and platform agnostic, we want to focus on a unified code base as such. Any other questions? Okay, next we move over to Manik to show an optimize demo, Octopi demo.
Okay, so talking about Octopi a little, right? So in the previous time when I came for a demo, I spoke about the SDX layer. So can anyone remember which service in SDX helped you get the lineage of everything within Cloudera? Does anyone remember what was the name of the service? Yes, it was Atlas, right? So Atlas helps you capture lineage metadata for everything and anything that happens within Cloudera, right? So what is Octopi now? So if we have Atlas, what is the reason for having Octopi with what Suraj just mentioned, right? So Octopi is more of a cross-system governance tool that we recently acquired, all right? So what this does, it does exactly what Atlas does, but it does it with external data sources as well, right? With Atlas, you can only see the lineage of the data entities within Cloudera, but if you had another data source, say for example, Oracle, SIS, Snowflake, anywhere, right? You could see the lineage of even data coming in from those data sources. That's what Octopi does, right? So I'll probably show you a quick demo with respect to a given scenario, and we will understand how it can help organizations, or how lineage basically helps organizations make their data quality better, right? So consider a scenario where one of the sales guys comes and tells the BI, the person who's creating BI reports, right? He comes and tells him that more recently, we've seen that the total product cost that has been coming onto the reports that we've been sharing is coming into negative values, which is not correct, right? There is something wrong that is happening with that total product cost. So now I, the user of Octopi, I want to go and see what exactly went wrong and how would I do that, right? So you get a very nice interface first when you log into Octopi. You see three different color coding here. The first one on the left-hand side is blue color, and blue color indicates your ETL pipelines, your stored procedures, right? The red color basically identifies the different databases that you have.
and the green is for all the reports that your organization has, right? So these are the different ways in which we can dig down. So what was going wrong? What was the issue that we were facing? Okay, so something was wrong with one of the reports where the total product cost was coming negative, right? So I will go and check that what is that report. So the report is top product sales. So this is the report that was specifically going wrong. And you can see that this is a Power BI report that is being generated. Now I want to look at how is this report being generated, right? What are the different systems that are involved for me to get to this specific report? So I will first look at the cross-system lineage. So Octopi gives you 3 different dimensions of lineage: cross-system, inner system, and your column level lineage. Okay, so we will talk about all 3 of them one by one. We will start with the higher 10,000 feet view of the entire thing, right? So we will look at the cross system lineage and see how it looks. So for that report to get generated, what is required? We can see that that specific report is being fed by 4 different tables. And these 4 different tables are being generated by all these different ETL pipelines, right? I want to get into my report and see how this specific report, or what are the different columns, tables that are involved, right? So now we are looking at a cross system. There is reports, there is ETL processes, there is databases, right? Now I will get into the inner system lineage. I want to see how this specific report is being built, what are the columns and what are the tables that are being used, right? So this is how the inner system lineage looks like. Now for me, this is important because this is the row that is going wrong, right? Someone told me that this row is coming into a negative value. So if I have to do analysis as to what's going wrong, how was this how did we arrive at the total product cost, then I will be able to tell what exactly happened and why is it coming into negative value, right? So if I click on this, you will see that this is how this specific column is flowing from that source to this destination. But this does not tell me how total product cost is being calculated. I need to get into the column level lineage for this specific column and see where did it originate from, right? So what I can do is I can click here. I can say end-to-end column lineage, and this will give me a bigger view of the entire journey of that specific column. So from where did it come, what happened to it, and where did it go after that, right? So this is the complete journey of that specific column. If I were to zoom in a little here, you would see that at this stage, there was no total product cost. There are 3 different columns: order quantity, unit price discount, and unit price, right? So based on these 3 different columns, we are deriving this attribute. So now I know how this column is being calculated, right? I want to go and check the script which is doing this now, right? So what I'll do is I will click here. I will go into the inner system lineage of this specific process, and this will give me what is exactly happening, that we are arriving at all of this, right? The total product cost you can see here. And if I go back to the lineage, you can see that from this table, it is picking up these 3 different columns. There is a script that is running here. And if I double click on this, you will be able to see the SQL script here, right? So you can see that the total product cost is being calculated in this manner, right? So now I know where I need to go and check, what column I need to go and check to figure out what's going wrong with total product cost, right? So this way, we can basically go and understand the complete lineage of where a specific data is coming from, a specific column is getting derived from, and we can take actions based on all of that, right? So Suraj spoke about Optimize AI, right? So there is AI capability built into Octopi. Everything has AI now except humans. So we need to have AI here as well. So if I click on edit live lineage here, you will see that the script comes in here. This is the live lineage. And if I make any additions or deletions from this specific script, right, I can see how the downstream tables would be affected. It's a very simple flow, but it gives you an idea as to what you can do with your scripts and how you can visualize what happens with your scripts, right? So this is a very powerful tool. And if I select Optimize AI here, this again gives me capability as a SQL assistant, if I were to call it, right? So if I want to find any errors within this, or which could potentially lead to some problem down in the future, I can just hit error detection, right? And it will tell me that what kind of issues it has identified and what you can do to resolve that, right? Again, AI in action. So this is one capability. Within Optimize AI, you also have the capability to optimize your existing SQL, right? So if you want to make it better, how you could make it better, you would get suggestions with respect to that. Interpretation. 10 years back, some SQL developer wrote a big SQL script. I am a new joinee and I'm looking at it and I'm getting scared, right? I don't understand what that SQL script does, right? Which is usually exactly what happens. So it also helps you interpret that script in terms of what it is doing, what is the final result going to be, what are the tables it is using to arrive at it. So it gives you the interpretation of all of that. And I think this is the feature that I like the most, which is your migration assistant. So this, if you look at it, it's a script that is running on a SQL server, right? Tomorrow, I want to understand that if I migrate this specific data set to another database, right? So from, say, SQL server, I want to migrate it to any one of these different data sources, right? If I just select the data source, it will give me the changes that I need to make to an existing script for it to be able to run on Hive, right? So it even gives you certain sort of assistance if you're looking to migrate workloads from one type of database to another different type of database, right? So it will give you these kind of assistance. So I think this tool is very powerful for big organizations who are managing big data sets, right? So if someone comes and asks them a question that if I change this specific column, what is going to be the effect of that changing that column, right? If we don't have this kind of a tool, it's a very manual process. So you will have to go and look at databases. You will have to see how it is flowing, from where it is flowing, and all of that, right? This makes it a whole lot easier. So when companies have to be compliant, they need to share auditing information, all of that. It's very easy to show regulators all of this and say that everything is being governed and taken care of. We know where the data is coming from, where it is sitting, and who is using it, and what way they are using it, right? So everything is there for them to look at and be comfortable with this, right? So this is a new ability or a new, and this is completely SaaS. Cloudera on cloud is a PaaS offering, which means platform as a service, right? So we give you the software, you bring in the hardware, but with Octopi, it's a SaaS offering, right? So you get it ready to use out of the box. So you don't have to go and install it. As soon as a customer raises a license, they will get Octopi out of the box, right? So this is something new that we've just added to our stack. So thank you. Yeah.
No, SQL migration is there from one.
Sorry?
SQL migration is there, right? Migration assistant.
I think it's
migration assistants, right?
Yeah.
Only simple SQL statements are like stored procedures, functions, packages, which
All those scripts can be transformed from here.
all.
Yes.
Thank you.
And I wouldn't say that it would be the exactly correct transformation. That's what happens with AI. It gives you a starting point and then you build from top of that, right? So, all right. Thank you, guys.
Manik, stop sharing.
Amol, so one thing that I missed was that I felt was really important is the vision or the roadmap on the next 2 years. We are already a hybrid company where the same workload can run without any changes on AWS, Azure, or cloud providers. We are also we are taking this beyond to the next level where we say true hybrid, where a workload which is running on-prem, like most of these AI ML workloads, you need additional compute. You need that flexibility, right? So say you have a workload on-prem, you could scale that to the cloud and scale down back. So that's something that we are aggressively working on as well. That is what we call the true hybrid, where the same job, same code runs across multiple cloud providers with no change.
Thank you. Okay, so you may be wondering the lot of jargons, lot of things that we talked about, which is outside what an usual developer looks at, right? See, if all of you are looking at building a career to be a data architect, These are all the things that you will eventually see. And exposure to these things early in your career is always a great thing, right? Be it compliance, be it optimization, be it hybrid, are all things that you as a data guy or a cloud person should be looking at. So now that we covered most of Cloudera, see, it's always good to hear on directly from customers on how they have implemented a specific product. So people who are part of, let's say, an OEM company like Cloudera AWS always talks about why is it good, more of selling thing, right? But what we really wanted to do slightly different in this community event today is get one of our customer to come and talk about their journey so that you get exposed to the challenges that they faced both internally on the platform side and how did they maneuver those challenges to adopt a platform which really gave them a true value. So today I'm more than happy to welcome Amol, who's also a great supporter of Cloudera. So he is a vice president at Axis Bank. He heads the whole Cloudera platform, someone who really stood as a big supporter for Cloudera to get our cloud up and running. At the same time, is also responsible for our platform, which is running on-prem. So if you are really looking at first-hand experience from customer who really worked on both Cloudera's on-premise solution, Cloudera's cloud solution, and this journey, there's no better person than Amol to talk about it today. So please.
Hey, thanks, Vinay. Hey, hi, everyone. This is Amol Kavle, and I'm working for Axis Bank since more than 5 years now. Okay. So in Axis, we have on-premises Cloudera platform, as well as we have set up the CDP public cloud platform. So when it comes to the platform, why platform is important, right? Because if you see any TV show, whether it is dancing show or singing show, you need a platform. Because nowadays people are getting more platforms, and that's why we are getting new stars. So platform is always important for me, at least. If you look the bigger companies like Google, AWS, and all, they are spending a lot of money on building their platform on infra or hardware, I can say. Because the way you give the platform to the users, you will get that kind of results. So it is very important for us to create a robust platform, scalable platform, flexible platform. Okay. So before almost 5 to 7 years back, this journey started with the Cloudera of Axis Bank. So we have started with the on-premises Cloudera platform first, and we have spent almost like 3 to 4 years on the on-premises platform. And after that, because if you know that, many of the people are working on different organizations over here. So if you want to procure new servers onto the on-premises platform, there is a big procedure in every organization, at least in the banks. Because if you want to add some nodes into your, cluster on the on-premises side, you need to have a word with the vendor first. You need to get a different quotations from the different vendors, then go to your procurement team. Then they will they will negotiate the deal with them. Then they will get the, PO raised. It will take almost like 15 to 20 days to get the PO approved. And after that, actual order will get placed. And after 1 or 2 months down the line, you will get the actual servers. So that's why we need to have some flexible platform where we can scale our infrastructure and run our use cases. And that's why we go for this cloud journey. Now question arises, why Cloudera only? Because we can't just say that we love Cloudera. I loved it. That's not the problem. But when it goes to the higher management or InfoSec, they will definitely ask why you need to go to the Cloudera CDP public cloud only. So the answer to the question, this question is like, we have different parameters to, get this decision. So first parameter is the flexibility. Okay. Because you have the on-premises cluster in your Axis Bank. So if you want to replicate the data from on-premises to the cloud, it will be easy if you have the both the side Cloudera component. If you have some other components as well, that is also easy. But when it comes to the complex use cases where you can have certain portion on the on-prem and certain portion on the cloud, and that's why we choose Cloudera CDP public cloud. Okay, then other factor is like cost effectiveness, because both the side you have the Cloudera, so Cloudera will give you the great discounts. Third part is scalability. Because it is on the cloud, definitely you will get the scalability option over here. Okay. And then increase security and all, that is fine. Many people have talked about, what kind of security and all that I will going to cover in my other slide. Okay. Okay. So this is well, first of all, I would like to tell you that, I am going to talk about what things I face during the implementation of this hybrid cloud architecture in my organization. Okay. So you can see that on here, there are 3 parties involved. First is the Cloudera. This is customer on-premises environment where we have the Cloudera on-premises cluster. Okay. Second one is customer AWS account, where we are going to actually execute our workloads or where we are taking our data to run our workloads. And third one is Cloudera AWS account. Why Cloudera AWS account? Many people here said that there is a Cloudera control plane. So Cloudera control plane is hosted by Cloudera in their own AWS account. So what we need here, there are many things we need to, achieve over here to create this hybrid architecture. So first of all, I would say there is a first major criteria is that connectivity. So how you will going to connect your AWS account with Cloudera AWS account? So the many people I can see here, they are learning cloud and all, and they want to create such kind of projects in their organization. So can anybody tell me what are the different ways to connect one AWS account to another AWS account? Yeah, anybody? Oh, yeah, organization, yeah. AWS organizations, okay. Cross account role is something kind of IAM level thing. I'm talking about the connectivity. Peering. VPC peering is one of the option. Then another option is internet proxy connectivity. Then another option is transit gateway. Then MPLS connectivity or direct connectivity, you can say like that. Okay. So as per your requirement, you can choose different kind of option. If you have the security concern, then you can directly go for the direct connectivity. If you have some cost related issues or so, then you can go for this internet proxy connectivity as well. Okay. So accordingly, you need to take a decision over here. Okay. Secondly, the thing is like, if you go for the private connectivity, definitely cost will come into the picture. Okay. Because there is a heavy cost requirements for the private connectivity. Okay. Then we have the private link connectivity as well, where you can use the AWS backbone network to connect with your Cloudera AWS account. So according to your requirement, you need to choose one of them. Okay. After that, because you are using the Cloudera control plane over here. Okay. So if your users from your organizations want to log in into this Cloudera control plane, what do you need to do? Anybody have an idea? SSO. SSO or SAML integration you need to do. So when it comes to the SSO, there are many ways to do that. One, you can do the Azure AD integration over here. You can do the ADFS integration or SAML integration like that way. Okay. And once you've done the SAML integration, there are users and groups which are present in your on-premises cluster. They can go reflect on this public cloud as well. But there are certain conditions, because on the CDP public cloud, they are supporting the usernames or group names starting with the alphabet, not with the actual number or so. So somebody, let's say, if you have your user as your employee ID. So generally employee IDs are starting with, let's say 1, 2, 3, 4, 5 or something like that. So when that user will come into this CDP public cloud, it will show it as U_12345. So then you need to decide how you need to integrate it, as well as for managing the access on both the sides, on the on-premises and cloud, you need to create a strategy first. Because in Axis Bank, there are multiple teams which are going to access this CDP public cloud infrastructure. Okay. So if you want to make, public cloud users or groups handle in a different manner, or on-premises users and groups handle in a different manner, then it's quite complex for an admin to manage those accesses. If you sync the users or groups from your on-premises cluster to the cloud cluster, you can create a similar level of, architecture on the on-premises and cloud. Let's say you have created some HDFS directories. Let's say one for is DBAT, another is for Bharat Banking, another is for data science, something, this kind of groups you have on the on-premises. Similarly, this kind of file system you can create it on the public cloud as well, and sync those groups from on-premises to the cloud. So they will get a similar kind of access at both the sides. And it is easy for admins or architect to manage this complex architecture. Why I say the complex? Because there are three parties involved over here. One, Axis data center or any bank's data center. Another one, bank's AWS account or any cloud account. And then third one is the Cloudera cloud account. So to manage these three things, you need to be very careful. Okay. Because one of the best example of managing three parties is Maharashtra Sarkar. You know how it's going over there. Okay. So jokes apart, but when I started this journey before 2 or 3 years back, it took me almost 2 years to complete this journey or to set up this platform in the Axis Bank. You know why? Anybody? You don't know? Sorry? Correct. Security. One of our best friend in every Indian bank is security or InfoSec, right? Because when it goes to the cloud, or rather it is on the on-prem, the security part is very important. How you are going to integrate, how the data will be safe on the CDP public cloud, because all the banks are handling very critical data and financial institutes, right? Whether it is customer ID, name, number, account number, card number, PAN number, Aadhaar card, and many things. And when it comes to the audit, you need to show them that these are the masked or encrypted. These kind of things you need to do. So to do this security, you need two types of security things you need to set up. One is over the transit and another on the rest. Okay. So over the transit, the answer is quite simple, or majorly people already said that we can use the TLS certificate or TLS 1.2, 1.3 kind of certificates. Now, the challenge over here is that in the CDP public cloud architecture, these Cloudera accounts, they are using their own CA certificates and their own domain. Let's say if you are working for a Google, so generally in Google, they will use the domain as a google.com or whatever, google.co.in, something like that. Like for every organization, I am using Axis domain. But when you go for this architecture, you need to convince your InfoSec team that, no, this is a hybrid architecture and here the product is behaving like this. So sometimes that product has certain capabilities, and over the period of time, definitely we will get the every feature. Okay. But when you start, you are facing these kind of challenges. So we have to convince our InfoSec team that they will going to use their own CA certificates and they will going to use their Cloudera.site. Anybody heard about Cloudera.site? Whether it is a public domain or private domain? Tell me. Have you heard about Cloudera.site? Most people will think it is a private domain. It is not a private domain, it's a public domain. But again, by using this public domain, you need to map your this public domain URLs to the private IP address of your organization's EC2 instances or EKS nodes. Because every URL which got invoked in this CDP public cloud architecture that have the URL as a Cloudera.site. So now the question comes, how these URLs will get access in your bank's network or your organization network? How you will resolve these domains or URLs or APIs? Because you need to integrate the CDP public cloud setup with your rest of the systems as well, who is currently present on your on-premises side. How you will do that? Or rather, I can say, ask the question as, if you want to access this CDP public cloud URLs from your home, because many of people nowadays working from home and as well as from office. So because office have different strategy to access the URL. In office, you have your own DNS servers. Those are resolving the URLs and you get the page. But for this Cloudera site, how will do that? Not you can do the VPN as well, but I'll tell you how I do it in my office and VPN. Okay. So when it comes to the VPN or working from home option, because there we are using the public DNS, not the anybody organization's DNS server over there. So it will go via public DNS to the AWS Route 53 domain. And from there, the URL is get resolved and it is pointing to your private IP address. So let's say you have the URL abc.cloudera.site and it is pointing to your EC2 instance 10.9.9.9, let's say. So you can resolve this URL with the help of AWS 53 route DNS server. But when it comes to the organization office network, you are sitting in your office and you want to access the CDP public cloud URL. How will you do that? Because your organization don't know the Cloudera.site domain. So, yeah, sorry. No load balancer. First of all, what you need to do, you need to create one conditional forwarder on your organization's DNS server. So whenever you are accessing any URL, let's say abc.cloudera.site, if you are on your office network, it will go to your DNS server. Your DNS server will see in its own database that there is a conditional forwarder has been set up. So what we need to do with this conditional forwarder? You need to put the IP of the free IPA servers, which is available on this public domain, public AWS account, which is in the Axis Bank's domain only. So all the infra and all the data is residing the organization's AWS account. Only Cloudera control plane is hosting on the Cloudera AWS account. Okay. So on this Axis Bank AWS account, we have one service called a data lake. Under this data lake, because this is the base of every service which all the people talk about, whether it is a data hub, Cloudera AI, data engineering, data warehouse, operational database. So for running all these services, what you need? Data lake. When you start with your journey for this public cloud, you need to set up a data lake first because it's a base service. Under this data lake, we have the different components like free IPA, and there are other like a DNS and all kind of service. So when you set up a conditional forwarder on your on-premises DNS server, you need to mention the IP of the free IPA server for this Cloudera.site domain. So when you access any URL or from your organization, it will check that conditional forwarder and go to the public cloud domain and resolve that specific URL, and you will get the actual page. Second stuff, important thing, control plane. Cloudera control plane is available all over the world, right? So if it is available all over the world, anybody can go inside that, log in with their Cloudera credentials and can see my data, right? So there is no security over here. How we can achieve that? So when we are setting up this project, there are two requirements for the Cloudera. whether you guys need to use a private IP address and public IP address. So our InfoSec denied about the public IP address. We can't use the public IP address in our AWS account. We can only leverage this setup with the private IP address only. And there is a boundary to access this private IP address. You can't just go on any computer which is available on the internet and access the cloud data control plane, but inside that, you will not able to see the Axis Bank data or anything related to the Axis. So that those who want to set up this in their organization, you need to keep in mind, because there are two ways. So when you goes to the connectivity, you need to understand all these parameters, whether you need to use public IPs or not. And you need a 3 to 6 subnets to run this complex architecture. Okay. So that was about this connectivity. Now, second part is like, many people are saying that on cloud, it is very easy. You just click on one button and everything will get set up within, few hours. Is that the case, Vinay? Those who are the admins or architects and they have set up this product or maybe any other cloud product, it's not that easy. Because when it comes to the organization, your organization is not open for every URL. There are many things which you need to do at the backend. So my BIU team or business team asked me that, hey, why would take almost like 6 months to do the POC? So I told them that for doing a POC, I need to convince many people from my organization, whether it is a InfoSec, whether it is a proxy whitelisting, whether it is a network, whether it is a cloud security. I want to go to each and every person and talk to them that I want to set up this project. This project is behaving in this manner, and we need to change certain things as a processes in our organization. Because this is not a traditional setup. This is not a single server setup. So we need to understand all these things. Those who are the just pass out or getting pass out and they want to, create a, work as an administrator or, architect. For this, they need to understand all these things, because many of the sessions I see that, everybody is appreciating this Java developers, Spark developers. They are doing this, they are creating rocket, they are flying from here and there. But you need to understand there are the platform admins and architects are also equally important, because to create a platform, it took many days, but to run a Spark job on that platform, it will hardly take 2 hours, because you just need to ingest the data and that's it. So it's not an easy job. And if you make the mistakes on the architecture level, it will impact you a lot. If you make operational mistakes, that is fine. You can troubleshoot it and solve it. But if you make the mistakes at architecture level, you need to pay for that, especially on the cloud. For cloud, for each and every byte or bit, you need to pay. You can't run the unoptimized queries on the cloud. I'll just give you an example. One of our dearest friend bank, they have created the Databricks setup in the cloud, and they got a bill as a 9 crore rupees for 1 month. So you can imagine how much dangerous this platform to manage. So whenever you guys are pushing pressure on your admins in your organization, just make sure that try to understand their problems. It is not that easy, right? And that's why I given the example of those platforms, because there are many things you need to do at the back end. Okay. Now comes to this public cloud architecture. While setting this public cloud architecture, you need images from the Cloudera repository. And if you're working for any banking organization, before using any images in your infra, you need to harden those images first. And then only you can use it, because there are many vulnerabilities you need to face later. Then how you solve it? because Cloudera is not sharing their images with any of their customer, not with us as well. Still, I like them. That is a different thing. But how will you do that? Then is this all together, you need to create a different process for this kind of new technology. Not in the for Cloudera perspective, but if you go for any new technology, whether it is Databricks, Snowflake, AWS, Google, anything, you can't stick with your traditional approaches to set up those technologies in your organization. Because there are many things we need to do it in a new manner. Because previously we used to run the RDBMS system, run some queries on the Oracle, get the report out of it, do the analytics. This way the organizations were running. But now that is not the case. We have the different technologies like Cloudera, Confluent, ELK, now AI. How will support that? And let me tell you one thing. If you're working for any Indian bank, especially, you need a courage to set up a new technology. I'm very much serious over here because this is not an easy thing to understand anyone that we are going to do this technology in our organization and you need to provide approvals for these things. For every single approval, you need to convince them this is how it works. This is the security ways which we are using it over here. Now it comes back to again this images part, how you can harden it. So what we have created is like we have created two environments. One is the red and one is the blue. So on the red environment, we are trying to implement this project, images first, creating the cluster over there. Then we are scanning those clusters, get a report of the vulnerabilities of those clusters. We will harden those images over there, and then we use it in the production side. Right? So that is one of the security thing. Now it comes to the data, because everybody wants data. They want to do the analytics. They want to run the AI models. So what kind of data you will give to the models, that kind of results you will get it. Right? If you put the apple seed in the soil and looking for the mango, it will not work. So like that way, if you want some good analytics or predictions, you need to give the data as well equally important. And on top of that, you need to create a security. So when it comes to the data security, especially at the rest, because transit, we just spoke about TLS certificates we can use. But when it comes to the rest, how will you do that? There are ways. First, especially in this CDP public cloud architecture, we are storing all the data onto the S3. So to make the S3 secure, you can encrypt the entire S3 layer by using KMS keys or HSM keys. HSM keys are more good because those are organization keys and you can't share those keys with anyone. So you can use the HSM keys. On top of that, if you have the PII SPDI data, anybody knows about the PII SPDI data? What is PII? What is SPDI? I know it is a time for lunch. I'll take hardly 5 minutes and then I'll wrap up. Correct. Personal identifiable information, and SPDI sensitive personal information. So like a account number, card number, like that. And personal information is nothing but mobile number or your name, email ID, like that way. So when it comes to the bank, you need to secure all these fields and you need to run the analytics as well. So for doing that, what you can do, you can create a hashing or masking on these fields with the help of Atlas and Ranger. Just many people spoke about it, right? So I like the one thing about Atlas is that you can directly classify the fields on the Atlas. Let's say if you have the mobile number, you just search on the mobile numbers from your Hive database and you can classify the fields over there. And then go to the Ranger in the tag-based policy and make it hash for everyone. It is just like, some few minutes of work, not much. But there is very good tools integrated by the Cloudera. I really appreciate it for that. Then later part is that, I'll go to IAM policy. What is IAM policy? Many people knows about AWS here. What is IAM policy? Sorry? Correct. Identity access management. Because there is a Cloudera AWS account where the Cloudera control plane is hosted. And users are logging over here and running the workloads on Axis AWS account or any organization's AWS account or any cloud account. So you need to give access to the Cloudera AWS account that you can run the queries in my account. And for doing that, you need to create a IAM policy, which is available in the Cloudera portal. But there are two policies. One is a full-fledged policy and another one is the minimal one. If you go for the full-fledged policy, then there are certain unnecessary rights also you are giving to the Cloudera. But in a banks or some organization infosec perspective, you can go for the minimum one, or you can customize the policy as well. Because in our organization, we have certain things called SCP, security policies, which is created on the AWS account. So you just can't go on the AWS and create some policy and do your job, because many things will get blocked. Then again, you need to go to InfoSec and ask for this kind of approvals, because I am using the Cloudera control plane over here and we need this kind of actions. You can give this 10 actions, don't give us rest 50, and create your policy over there and run your workloads. It will be win-win situation for both of us, Cloudera as well as the customer. So that is the IAM policy. Then I'll go to the one of the interesting thing which I like. I don't think I mentioned over here, but that is called the observability. Right? So what is observability? So in observability, you can not only give the chargeback to the customers because they have run set of queries into the cloud and we need to give them a charge. Your users have run this much of queries and this is the cost for them. Just give us that cost back because we need to give to the Cloudera, right? And that's why Cloudera is $1 billion company. And we are also quite give short push to them to reach over there, right? So coming back, the observability part. So in observability, not only the financial governance is the aspect, but there is another aspect called the analytics. So where you can see not only your cloud clusters, but your on-premises cluster as well. And from there, you will be able to see which are the users which are creating harm for the cluster, right? And you can see what kind of queries are get run, whether those are optimized or not. And if it is not there, we can inform users to optimize the queries and run to the cluster, whether it is a cloud or whether it is a on-prem. So I like this feature a lot, and I'm very much thankful to Cloudera that they have created this and integrated with on-premises as well. Okay. And not only the queries, you can see the node utilization, Spark queries, Hive query, Impala query, which are the jobs are, don't have the optimization, dynamic allocation is not used, data skewness is there, right? They have used inappropriate resources in their code. So all these things you will get it in a one single view. And that is very nice view given by the Cloudera. And to tell everything, I have a lot of things to do, but there is a time limitation. I need to go to Mumbai as well. So I'm stopping here. And thank you very much for listening to me for the last 30 minutes. Thanks a lot.
Hi, everyone. So welcome to my session about creating serverless NiFi flows using AWS Lambda and Cloudera DataFlow. So the question is, does your enterprise need to integrate maybe multiple diverse types of data into your data platform? Or as a developer or an architect, do you get a massive headache when you think about all the different types of data that you have to integrate into your data lake? If the answer to either of these questions is yes, then I think that Apache NiFi could be of great help to you. In this session, we will have an introduction to Apache NiFi, which is a tool for automating data flows between various systems. And we'll see how to create NiFi flows using Cloudera's own DataFlow. And lastly, we'll see how to create serverless NiFi flows using AWS Lambda and Cloudera. I'll close with a very short demo of how we can do it. A short introduction about myself. I'm Manu. I've been in the software industry for about 20 plus years now. This is my third year as a AWS community builder. I certified 3 times as in the AWS. Probably I enjoy stress and multiple choice crisis. Currently, I work as an AWS architect for the company Serverless Guru. About Apache NiFi. NiFi, the word stands for Niagara Files, which was a product developed by NSA, National Security Agency of USA, in 2006. In 2014, it was donated to the Apache Software Foundation as an open source software. Since then, it has grown, and currently it's used by thousands of enterprises around the world for managing their data flows. Currently, it is in the version 2, and Cloudera is one of the biggest supporters for Apache NiFi. Here are some features of Apache NiFi. We use it to automate the data flow between various systems. Importantly, it has a low-code, no-code paradigm, which you can use to create the data flows, which means you don't need to learn a lot of coding and technology before you can start creating your data flows. It has a guaranteed at least once delivery paradigm, which means it's very different from booking an Uber auto here. There is a guarantee that it's going to come. We have prioritized queuing, which means you can set different types of priorities on your data queues, like first in, first out, oldest, first in. And we can even set the priorities based on attributes inside the data. And we can set different quality of service on the data flows, which means that we can choose, do you want to have big throughput, or do you want low latency? Like, do you want to get it faster, or do you want to push a lot of data? Or you can have flows where you are okay if some data is lost, or you want to have guaranteed delivery. And one of the most important thing is that you can track data provenance and lineage. Data provenance is like an audit trail. In a flow, you can see where the data originated, what happened to it next, who transformed it, what kind of changes happened to it, where is the data going, everything you can see. And we have lineage. I think in one of the previous demos, our Cloudera associate has shown us lineage in that demo. Lineage is like a family tree, so to speak, like where did this data originate, and who are the other people who made changes to it, and where it is getting stored, all that kind of things. There are a lot of applications for the NiFi, like ETL, obviously. We can do extract, transform, load using the Apache NiFi. Log collection and analysis. Now we have stacks like Flip, which uses NiFi with Apache Flink and some kind of a dashboarding system to create a full-fledged data platforms. We can use it for data migration. Because we have that provenance and lineage, we can be 100% sure that the data that I am moving from one system is exactly the same as it appears in the other system. We can use it for IoT data processing. So like in Apache NiFi, we have something called MiniFi. MiniFi is a lightweight agent that you can deploy on an IoT device, like a temperature sensor. It could be an automated car, a smart fridge in your home. So you can deploy that there, and it can send metrics, logs, and traces into your data platform. We look at the components here. We have a thing called flow file. Flow file is like the smallest amount of data. That's the unit of data and the metadata. Then we have processors. Processors are what actually works on the data. They are the compute. They can process the data, transform it, enrich it in various ways. The main thing about NiFi is that we have got about 450 plus processors already built and ready to use for you in the Cloudera DataFlow, which means you can just drag and drop those processors into your flow, and you can just start creating your data flow. You don't need to code anything. When you have multiple data processors and flow files combined in one unit, it's called a process group. It allows us to create a unit of things by combining them. And if you want to input some data into your flow, you have input port. And if you want to output the data somewhere else, you have an output port. So here it shows like a very simple example about the flow starts with get file. It gets the file. It gives you a flow file, which is actually the data and the attributes. We can convert the record if you want to convert or transform it. Then you are going to put the file somewhere else, like an S3 or something. These are some of the examples, like you can get file from a file system. You can consume it from a Kafka. You can execute a SQL query. You can run an OS command, FTP. A lot of things are there. Even today, even they have advanced processors, like you can run RAG processing using these processors. You can fetch from Pinecone and previous lot of things. We go to Cloudera DataFlow. Cloudera DataFlow is the product for using Apache NiFi within the Cloudera platform. It is a managed service for Apache NiFi. And Cloudera currently is the only vendor supporting NiFi 2.0, which is the latest version. And as I said, we have 450 plus process available for your data that you can start using from day one. So this is how the process will look. First, we will design that flow using something called a flow designer. This is a GUI wherein you will drag and drop the components and create the flow. You test it, and once you are satisfied that it's working, you can publish that into a central catalog. Catalog is nothing but something like a GitHub repository you can think of. So once it is in the catalog, you can deploy that and start running it on your production or some environment. There are two options for doing that. One is called a deployment. This is like you have deployed that flow on a NiFi cluster, and it will keep running all the time. So this is for long running jobs that you want to keep on running all the time. Say you have IoT data or clickstream from your website coming in 24/7. So you want this option there. But what if you want to run this data intermittently? Say you have a process running at some point of time in the night. You have a file coming in and you want to process it then. You don't want to keep running it all the time. That's where you go to this one called DataFlow functions. So this uses serverless functions. In AWS, we have Lambda. In Azure, we have Azure functions. Google also has their own version. So we use those serverless functions to deploy the NiFi flow on that, and then we can run it intermittently based on a trigger without worrying about servers or having a long running process. Now I would like to play a small video about how we would actually create this kind of a flow. In this video, I'm showing, hello. This video, it shows how we will develop a NiFi flow on your desktop. You can just download the NiFi software from the Apache NiFi and start developing a flow. It's a very simple flow here. I have got 3 steps. The first step will go to this API endpoint and query for the current weather. So I have given Bangalore here. It's going to get the current Bangalore weather in JSON. Then I have a convert record here, which is a processor that can read a JSON and write a JSON. So I just gave these parameters. I didn't have to code one single line to create this data flow. So now I have the JSON record. Then I have something called a put S3 bucket, which can write this file into my S3 bucket in US East 1. I also have a service called Apache AWS Credential Provider, which is also something already provided within the NiFi. I just have to give it some way of connecting to the AWS, which is currently, I have used AWS access key and a secret access key. I could have also used a role or a profile name or one of the other advanced ways. But for this demo purpose, this is fine. So I have created these 3 steps in about 5 to 10 minutes without writing one single line of code. And now I can start running this process. I stopped everything and I click on run once. It's going to run the invoke HTTPI one time. So this is running in my desktop. It takes some time to query the API endpoint and get the output. In about some seconds, the output will come. So it has come now, and we can see it's about 49 kilobytes, and we can see what the data it has fetched. So here we can see the data that it has fetched, the provenance, lineage, all those things. I click on details, I can see how much time it took, how much data it is there, what data it fetched. So we can see the data that it has fetched. It feels like 28 degrees, humidity only 66. So basically the Bangalore weather that we all love. So it has fetched that. It's in JSON format already. I go back to my flow. So here I can also see the provenance and lineage. So now I invoked this HTTPI and I have downloaded that response. So those 2 things have happened on this data because only one step has completed so far. So here I can see the lineage. The download happened before that it received. And I can even go back in time and see what things happened to this data. This also means that you can track the data as it is going through the data flow. And if you want, you can even replay them. So now we will just go to the next steps. So it converts into JSON file, writes it into the S3 bucket using the put S3 bucket. And now we will go into the S3 bucket and see if the file has been created there. So this is my S3 bucket. And as you can see, a new file has been created here at the same time that we saw in the JSON file. I will open this file. It has created with the same file name that we gave in that project, NiFi with our JSON. I will open this and we can see that it has the same data that it was there. So this is just a small example of how we can create a flow. So now we have created the flow and now we want to deploy that on the Cloudera DataFlow. So this is the Cloudera screen. Here you have a flow design screen, flow designer, where you can do the same thing, but on a web UI. You will click on that create draft and start creating this same flow, but with a web UI. And when you are here, you have 2 options here, NiFi 1.x, which is a stable version, and 2.x, which is the latest version. This is my flow within the NiFi flow designer inside the Cloudera. And as we saw previously, this is again a 3-step process. But instead of an invoke HTTP, here I have another process called generate flow file, which just creates a flow file as per the specification. I had to do this because this is a trial account and I didn't have the access to call external APIs. So it just creates a file as a JSON file, one attribute called date. The value is current date time. Rest everything is as is we saw in the other one. It creates the JSON file, it puts it into the S3 bucket. We test it and we see that the date is coming fine. In this one, I also I test it and see that is correctly going into the S3 bucket with this name that I have given. Everything is fine. So once you have tested it fine, the next step is to publish it. So here I click on publish. This will put that into the repository that I talked about before. It's called the catalog. On the left-hand side of the menu, you have these options called catalog. So this is the repository. It's like a GitHub. It keeps the version numbers and everything. So I select to publish it. I have already published this version here. It has something called a CRN number here, which is like a points to that specific version of the flow. So once you have published this flow inside the Cloudera DataFlow, you are all set to deploy that into wherever you want. So if you want to deploy that into a long running cluster, you just click on this deploy. So if I click on the deploy, it will just deploy that into my NiFi cluster, which looks, which I can see from the deployment menu. This is something that I already deployed there. I can check the deployment. I can view that in a NiFi canvas. It's just like the NiFi view that we saw before on the desktop. Only thing is that this is my actual environment running in cloud. I can go into the process group and I can see the different processes that are there inside that. This is the three-step process that we have. It creates a file, it converts to JSON and puts it into the S3 bucket. So here again, if you want, you can see the provenance, lineage, all those things. So now we are, now we can see that the provenance, the lineage has more steps because it has all this, all the steps have been done. And if I want, I can go back one step and reprocess that again. Now let's create that in AWS Lambda. So I come to this part called functions. Functions, it shows the three different options for Azure, Google, and AWS. We are going for AWS Lambda because it's my favorite here. And AWS Lambda has the benefit of running code without worrying about what server it is running on. It can scale very nicely up to any amount that you want. And if you already have some workload running in AWS, this gives you the ability to integrate to other things that you might have running on AWS, monitor it with CloudWatch and CloudTrail, all the good stuff that comes with running on AWS. Let's skip forward a bit. So we need three different information to run this. One is that CRN number that we saw there. And then we need two parameters from the Cloudera, which will come from, if you're on a trial account, it comes in the trial information. It's an access key and a private key for your data flow. So once you have these three information, you are ready to deploy that on AWS Lambda. You go to Lambda, create the function. The type is Java 8 on AWS Amazon Linux 2. As you can see in the runtime, it says Java 8 on Linux 2. And the handler is always the stateless NiFi function. We download that a zip file from that download, which will be the actual code inside the Lambda. So we put that zip file into an S3 bucket, and then we ask the Lambda to just take it from that bucket. So this is the bucket, and the zip file we got from the Cloudera. So we put that into the Lambda. Now we are done with the Lambda mostly. We just have to set up some configuration environment variables. We go into the configuration where we have environment variables. Here, as I said previously, we have these variables here, the flow CRN number. This is the CRN number for the flow from our GitHub, from our catalog. DF access key, private key, these are the keys that we get from the data flow. And these two are the parameters that the flow is using to log into the AWS. I'm not worried about these keys here because these were temporary keys that I created for the demo and they have been already been disposed of. But in a production scenario, you will keep them much more secure. So now we have created the Lambda and we are ready to run that. I have created a function URL to run this. We'll just go to the function URL and invoke that URL to run this. We'll check in the CloudWatch to see how this is doing. This is the log group for that Lambda. Check the latest log stream. So it started running, it created the data flow and successfully downloads that flow that we have designed within the Cloudera using the CRN number. It has to extract the files from the zip folder that we are given, starts to going through one by one steps. There are no input ports, so there is no input. There are no output ports, so there is no output. But the other steps it will do. So once it has run, it says that the S3, it has put the file into the S3 bucket. I'm sorry, I think I went back a little bit. It does the generate flow file converting and put S3 bucket. So now that Lambda has completed running, we can go into the S3 bucket and see if the file has been created. So this is the bucket that we have used, and this is the current time when this demo was run. So the file has been created there, and we can open that and see that it has the exact date time when it was running. So we saw how to create the NiFi flow within the Cloudera DataFlow. As I said, they already have a lot of things for the advanced topic, things like Kafka, RAG, AI, etc. We saw the AWS Lambda, how it was working. We can do any kind of integration with the other things that you are running in AWS. We can centralize your monitoring and management. Cost optimization, very important when you are running in production. It only runs when you want it. It scales very nicely. There is no overhead of managing it, and you can deploy it very fast. So these 4 steps we have already seen. We developed the flow, published it to catalog, deployed it as a function, and then we monitored it using the CloudWatch. And if you want, you can improve it later on. The same kind of use cases exist here, but with function, etc., especially, it's more for real-time data processing, that you have data coming and you process it right then. You can, if you have some alerting and notification kind of things, this is another option. Or you want to process a document that's coming into your system. We did the demo, and I would close the session here. Thank you for your listening to my topic on NiFi flow. I hope that I have done it justice. If you would like to connect with me, you can use this QR code and connect with me on LinkedIn. Thank you. Thank you so much.